Dinosaurs are some of the most fascinating creatures to have ever lived on Earth. For over 165 million years, they dominated the land, from tiny bird-like species to massive giants that could reach the heights of modern buildings. Despite their enormous presence on the planet, all we know about them comes from fossilized remains, bones, teeth, claws, footprints, eggs, and occasionally traces of skin or feathers. The process of discovering dinosaurs is both a science and an adventure, combining careful study, fieldwork, excavation, laboratory analysis, and sometimes a little luck. Every fossil tells a story about a world that existed long before humans, offering glimpses into ecosystems, climates, and behaviors that no living species can replicate. The journey begins with geology, the study of Earth's layers, formations, and history. Paleontologists first determine where dinosaur fossils are likely to be found by studying maps and rock formations. They focus on sedimentary rocks because these rocks form in layers from mud, sand, silt, and volcanic ash, which are excellent for preserving remains. The rocks must also date to the Mesozoic era, which spans from about 252 million to 66 million years ago, encompassing the Triassic, Jurassic, and Cretaceous periods. Within these layers, scientists look for clues such as changes in rock color, texture, and composition, which may indicate the presence of ancient life. Once a promising area is located, fieldwork begins. Paleontologists and their teams often traverse deserts, canyons, cliffs, and riverbeds for days or weeks, scanning the ground with careful attention. Even a tiny fragment of bone sticking out of the dirt can lead to a major discovery. Experienced scientists can distinguish fossils from ordinary rocks by examining texture, weight, and subtle differences in color or shape. A single tooth or vertebra fragment may be all that is visible on the surface, but it can signal that a complete skeleton is buried beneath. Every discovery is carefully marked, photographed, and mapped because the fossil's position within the rock tells a story about the dinosaur's environment, behavior, and how it died. Excavation is a slow and meticulous process. The rock surrounding the fossil must be removed gradually to prevent damage. Scientists use a combination of heavy tools like shovels and pickaxes for overlying rock, and delicate tools such as brushes, dental picks, and air scribes as they approach the fossil itself. Excavation can take months or even years, depending on the complexity of the site and the number of fossils involved. Every layer removed is documented, and sometimes sediment samples are collected to study microscopic remains like pollen, spores, or tiny organisms, which help reconstruct the environment in which the dinosaur lived. Large fossils require special protection. Plastic jackets are applied to the bones, covering them in foiled burlap and plaster to create a rigid shell for transport. Some fossils weigh hundreds or even thousands of kilograms, necessitating the use of cranes, trucks, helicopters, or even pack animals in remote regions. The process of moving these fossils from field sites to laboratories is a logistical challenge but essential for their preservation. Once in the laboratory, the fossil undergoes preparation. Technicians carefully remove the plaster and clean the surrounding rock using precise tools. Some bones are so delicate that even vibrations or tiny movements can cause damage. To stabilize the fossils, scientists apply adhesives and chemical hardeners. Modern technology has greatly enhanced this process. CT scanning allows researchers to see inside bones without damaging them, revealing structures such as marrow, cavities, blood vessel channels, and signs of disease or injury. 3D scanning creates accurate digital replicas of bones, which can be printed in 3D for study, display, or reconstruction. When original bones are too fragile, identification and classification are key steps in the scientific process. Each fossil is compared to thousands of known specimens to determine whether it represents a new species or a previously described dinosaur. Scientists examine every detail: skull shape, teeth, structure, limb proportions, vertebrae features, and more. When a new species is identified, it is given a formal scientific name, often using Latin or Greek roots, sometimes combined with references to its location or discoverer. This new species is then described in detail in scientific journals, making it part of the global scientific record. Reconstruction of dinosaurs extends beyond skeletal assembly. By studying bone articulation and muscle attachment sites, scientists can estimate how the animal moved, how it stood, and how it hunted or foraged. Fossilized footprints, nests, eggs, and coprolites offer additional insight into behavior, diet, and reproduction. Skin impressions and rare fossilized pigments provide clues about appearance, including patterns, texture, and even possible coloration. Artists collaborate with scientists to create models, illustrations, and computer-generated animations, bringing these ancient creatures to life for museums, documentaries, and educational purposes. The study of dinosaur fossils reveals much more than the creatures themselves. Fossils provide evidence about ancient ecosystems, climate change, evolution, and the rise and fall of species. They show how plants and animals adapted to changing environments and how mass extinctions altered the course of life on Earth. Fossils also help scientists understand modern biodiversity and evolutionary processes by offering a long-term perspective on survival, adaptation, and extinction. Paleontologists face many challenges. Fieldwork can involve extreme heat, cold, wind, rain, and remote. Working in deserts or high cliffs requires physical stamina and careful planning. Despite these challenges, the thrill of discovering a new fossil drives researchers to continue exploring. Even a single fragment, such as a tooth, claw, or vertebra, can lead to the reconstruction of a complete skeleton and provide invaluable insight into the life of a dinosaur. Fossil discoveries often provide unexpected surprises. Some fossils reveal evidence of parental care, social behavior, or hunting strategies. Feathered dinosaurs, previously thought to be exclusive to birds, have been discovered in places such as China, showing that feathers were more common than previously believed. Injuries on bones reveal fights, predation, or accidents that occurred during the animal's life. Fossilized eggs and nests show nesting habits, growth rates, and even the development of hatchlings. Trace fossils, including footprints and burrows, provide additional behavioral evidence that skeletal remains alone cannot convey. Technological advancements continue to revolutionize paleontology. Virtual reality reconstructions, biomechanical modeling, chemical analyses of bone composition, and isotopic studies allow scientists to make more accurate inferences about diet, migration patterns, growth rates, and physiology. New discoveries are made regularly, from giant sauropods in South America to small feathered theropods in Asia, continually reshaping our understanding of prehistoric life. Despite centuries of study, much of the dinosaur world remains undiscovered. Vast regions of the Earth still hold fossils waiting to be found. Sediment-covered areas, remote deserts, mountain ranges, and river valleys may contain species that have never been seen by scientists. Each expedition carries the potential for groundbreaking discoveries that can change our understanding of ecosystems and the history of life on Earth. Every fossil contributes to a larger story of life on Earth. They showed how life adapted to different climates, how continents shifted, how species and how ecosystems evolved over millions of years. Fossils also help scientists understand mass extinctions, showing which species survived and which perished, providing insight into the resilience of life. They are not merely remnants of the past, but keys to understanding the processes that continue to shape the natural world today. The study of dinosaurs requires patience, precision, and collaboration. Scientists from different disciplines work together to interpret the evidence, from geologists and biologists to chemists, engineers, and artists. Each fossil adds to the knowledge base, providing new insights into the lives of animals that roamed Earth long before humans. Even partial skeletons or isolated bones can tell stories about size, diet, movement, and social behavior. Dinosaur research is ongoing. With every fossil discovered, our understanding of prehistoric life grows. The tiniest bones can reveal details about evolution, while large skeletons can show the dynamics of ancient ecosystems. New discoveries challenge old assumptions, such as the presence of feathers, unexpected behaviors, or unique adaptations. Each new species expands the tree of life, showing the diversity and complexity of the Mesozoic world. Dinosaurs are not just a window into the past, they are a mirror reflecting the processes that continue to shape life on Earth. Fossils reveal patterns of adaptation, extinction, and survival. They inspire curiosity, spark imagination, and drive scientific exploration. From the first fragment uncovered in a desert to the reconstruction of a massive skeleton. Every discovery is a bridge across millions of years, connecting us to creatures that once dominated the planet. The history of dinosaur discovery is far from complete. Fossils continue to be uncovered in unexpected locations, sometimes in extraordinary conditions. Scientists continue to develop new methods for locating, extracting, and analyzing fossils, and every discovery has the potential to rewrite what we know about the ancient world. Fossilized remains provide insight into evolutionary processes, environmental changes, and the incredible diversity of life that once existed. Studying dinosaurs teaches us about resilience, adaptation, and the impact of environmental change. Each fossil is a puzzle piece, helping to reconstruct ecosystems, predator-prey relationships, and the development of species over time. From tiny early mammals living alongside dinosaurs to massive predators hunting in herds. Every fossil provides a story about survival and life millions of years ago. The search for dinosaurs is ongoing and never. Vast areas of the world remain unexplored, and countless fossils lie hidden beneath layers of rock, waiting for discovery. Each expedition, whether successful or not, adds to our understanding of prehistoric life. The thrill of uncovering a fossil is accompanied by the satisfaction of contributing to science, advancing knowledge, and preserving history for future generations. Dinosaurs are more than bones. They are evidence of Earth's dynamic history, the evolution of life, and the incredible diversity that has existed on our planet. Every discovery brings scientists closer to understanding ancient life, ecosystems, and the processes that have shaped the world as we know it today. Fossils inspire, educate, and remind us that life is constantly evolving. The story of dinosaurs is still unfolding, and each new fossil adds another chapter to this extraordinary tale.